In this video, we want to solve a problem that's related to the sampling distribution of the sample mean. We have a population mean of 200, a population standard deviation of 50, and a simple random sample of size 100. So first of all, we want to write down what we're given in the problem, and we do that over here. So mu is 200, that's population mean. Sigma is the population standard deviation, and little n is the sample size. Part A says, what is the expected value of the sampling distribution of the sample mean? So that's actually a formula, because the expected value of x bar, which is what this wants us to find, is equal to mu. So we write that right here. So that's just the formula. That's always true if x bar is unbiased. And so because the population mean is 200, we know that the expected value of x bar is equal to mu, which is equal to 200. The next thing we need is the standard deviation of x bar, which is sigma x bar. Another name for this is the standard error of x bar. The formula for that one is sigma x over the square root of n. So we plug our sigma in and also our n. So that's 50 divided by square root of 100, which is 50 over 10, which is just 5. In part C, it asks us what is the shape of the sampling distribution of the sample mean. So what is the sampling distribution of x bar? What shape it is? Is it normal or not? Okay, so we can invoke the central limit theorem, and that says if little n is large enough, we can use a normal distribution for x bar. So little n is 100, which is definitely bigger than 30. Sometimes we use 25 as a cutoff point. So anything above 25 and 30 is considered large, and so x bar is indeed normally distributed. Now we need to get into some calculations of probability. So part D says, what is the probability that the sample mean will be within 5 or plus or minus 5 of the population mean? So what that means is we have to look at the population mean and see what it is, and again it's equal to 200. So we want to be within plus or minus 5 of that. So we're looking at 195 and 205. So what that means in terms of probability is that we're trying to calculate this probability. So what is the probability that x bar is between 195 and 205? And here I did a little sketch, and this is the bell curve. These are the 2 points looking for x bar. These are the 2 x bar values. So now I need to find the area under the curve between these 2 points. Remember, whenever we're dealing with a continuous random variable, the area under the curve is going to be the probability. So we just need to find this area. And lucky for us, we can use Excel to complete this. So what we're going to do, we're going to say, okay, what's the cumulative normal distribution up to 205? That's everything to the left of 205, including this unshaded area. And what's the cumulative distribution up to 195? Well, it's the unshaded area right here. And so all we need to do is to find the larger area and subtract the smaller area. So that's exactly what this formula is doing right here. So in Excel, we're going to type equal, then norm.dis 205. 200 is the mean, mu. 5 is sigma x bar, and then true for cumulative distribution. And we're going to subtract the same thing when we replace x bar with 195 instead of 205. Our final area or final probability is 0.6827. Part E wants us to find the probability that the sample mean will be greater than 210. So let's go ahead and write that out in terms of probability. Over here, we see that we need the probability that x bar is bigger than 210. We do a quick sketch of the bell curve. Our mean is in the middle here. So 210 is to the right of the mean, which is 200. and we want to shade the greater area because they said we want to find x bar greater than 210. So what's this area? What's this probability? Because our normal tables and Excel only gives us cumulative distribution up to a point, if we have an area that's greater than, we have to subtract from 1. Okay, so that's why we're subtracting from 1 here. So 1 minus the unshaded area, which is a probability that x bar is less than or equal to 210. Then we go to Excel and we plug this formula in, 1 minus norm.this, 210, plug in the rest of the values. Our final answer is 0.0228. Thank you.